Parameterized testing is when we want to do data-driven testing. For example, we have a function or method that we want to test with different parameters or input values. This lets you increase the coverage without having to add more test code. For this, we will be using the parameterized package of Python. This is the URL which you see on the screen. The good thing about this package is we can do parameterized testing for any Python test framework, for example Unittest or PyTest or Nose test. I'm Kumar and welcome to my channel on tech and tutorials. So before starting to write parameterized tests, let's see an example of the regular test, how we would have written if it was not for parameterized test. Say for example we want to test our add function. For example, we want to test with the value of 5 and then -2, and then we want to test with the value of -4 and then -3. For those tests we would have needed to write multiple tests for each one of these, like multiplication, division and subtraction. For all of them we would have needed to write separate test for all these multiple data sets. So let's see an example which I have put it in here. So in this case I am trying to add a value of 4 and -1, which should give us a value of 3, -5 and -1, which 1.3. So you would have needed to write all these scenarios in each separate test case. So, and that's not only for add, we would have needed to done for all the other functions, multiplication, division and subtraction. So that would require us to add so many code in here which can be reduced using the parameterized option in here. So before starting to write our parameterized way of writing test, let us try to run this file, test file, and see how it is working. So it ran 3 pass, so all of these are passed. Again, let's try to run it from here. So all of them are okay right now here. So let's try to build our parameterized way of writing test. So before that we need to install the parameterized, I have already imported it here, parameterized library in our Python libraries. So this is the documentation for parameterized library. Pip install parameters. You can just do pip install parameters, go to the terminal, and you can paste it here, pip install parameters, and it should install your parameterized library. And of course you can also do it from PyCharm. You go to the project interpreter and then select the Python for your project, and you should be clicking the plus sign here, which should show us all the available packages, and where you can type here Parameterize, and you should get it here. This one is blue because I have already installed it in my Python package list. You can see it here, parameterized here. So I have already installed it, and let's start to build the parameterized test for this add function. And let's go to new and Python file, name it as test. Select Unittest, and let me copy all these imports. Okay, and so we are going to do add test, add parameterized, and let's head over to the documentation here. If you see here in the documentation for unit test, we need to use this decorator parameterized.expand, and then we will provide the decorator before our method. So I will just copy this one and paste it here, and we'll go to and see what are the methods, what are the values which were the 4, -1 and 3 we want to test. So we'll put 4 here, and -3 we should give us a value of, sorry, -1 we should give us a value of 3 here. 3, 1. Make this a little bigger. So before doing this, let us actually initialize the class method here, and yeah, next what is -5, -1, -6. So -5, -1, -6. This is for addition, and 3.2 minus 1.9, 3.2 minus 1.3, 1.3, and here we are using assert almost equal here. So let us try to do this assert equals. Let's do an assert almost equal, because we need to be covering the last point as well. So 1.3, actually if I don't do this assert almost equal, I'll show you what is the problem. Assert equal, I don't do a delta here. I need to put the precision for this decimal digits, which actually throws up an error here. So once we add, it gives us all these digits after the decimal, but we are writing it one dot. So same thing we will use here, assert almost equal. And okay, before that we need to pass in these values here. So we'll just name this as 4 as 1, sorry, 4 as, yeah, so we need to add the what we are getting in this parameterized decorator. We need to pass into the method which we are adding. So I'll just input 1, I'll name it as input 2, and then our expected value as I'll just name it as 1. What will happen is, for each of these values, rows, for each of these rows, it will run this test. So there are 3 rows, it will run the test 3 times with all these values, and each of these values will get passed to this method argument. In 4 will go to in 1, and then the second one goes to the second, and the third one goes to the third one. So, and inside this we need to, so cal.a will put a value as in, self.cal.b value as input 2, and we will put the output in the assert method. So self.cal.add, and this will add the value of input 1 and input 2, and this should be the output, should be out, and we'll put a delta of 1 here. So this is actually done. Let us try to run this test and see our output. Test parameterized. Okay, so all of them are passed. So if you see the method name test add param 1 0 1 2, so there are 3 rows in here. So each of these they are naming it as 0 1 and 2, and all of them are passed here. So this saves us a lot of typing. We don't need to write so many lines of code. Instead we'll just pass in the parameter and it should start, and then all the values will be tested in one shot. So you can of course do the same thing for the subtraction, for the multiplication or division or subtraction. So that's all in this video session. I hope it was helpful to you all. Thank you.